Done.
So Jeet, he is from ISI Kolkata. He will be teaching this course of group theory problem sessions. I mean, as the name suggests, this will be a group theory class, a group theory course, mainly based on problem solving, so that you can crack the entrances like ISI, like Senate. I mean, those come in the next 5-6 months. So we will be solving problems from ISI, from NET. I mean, the exams that are just around say June and July, we will or May, we will be targeting those. CMI as well. Okay, a few ISER entrances here and there. So he will be teaching that group theory for that. So don't hesitate to ask him your questions. Every question will be entertained. Don't worry. It is absolutely accepted that you are not a genius, because if you are a genius, you don't contact us anyway. You can teach on your, you can study on your own. So no question is stupid. Okay. So Jeet, Shadan.
I do not have any question.
So Shadan has taken the course. Srushti has taken the course as well. So Jeet, Shadan is targeting for ISI MMath this year. So is Srushti, but their backgrounds differ a little bit. Srushti has done her graduation in computer science. She's pursuing her BA in economics. I mean, from a distance, and she has also learned quite well mathematics on her own. I mean, on her own, because she informed me last that she got 50.68 in a mock test of JAM. Okay, so she is, I mean, halfway there, but she is a little bit lacking in group theory maybe. So for the next 4 months, we will be guiding her for group theory. Shadan is here. He is from Rathi, I guess, Shadan. So he has also purchased this course. He will be doing that full crash course of MMath on MMath actually, and that metric space everything. And Piyash is here. Piyash has been with us for last 1.5 years. Piyash is the topper of St. Xavier's College, third year. Piyash, Jeet is actually your senior, your alumni. He is from the same college. Well, Kalpesh is here. Since the class is open, I believe, I mean, there will be a lot of students. So yes, Jeet, I mean, you can start, okay?
Okay.
So I'll just mute myself and I will take your leave, and then you guys can start. And I will just request you guys to do one thing. If you have questions, then please ask, because if you type it down, अगर तुम लिखते हो ना inbox में, if you just type it down in the inbox, the faculty can't see it. I mean, in Google Meet, when he's sharing the screen, he can't see your text that you are sending in the Google Meet. So please ask him, okay? Or at least if you are noticing somebody is texting, at least tell the teacher that just hold on a moment, somebody is texting, or somebody is asking a question via text. Okay. Okay, carry on.
Okay, thank
All
you,
the best.
Rudra.
Hmm.
Okay, so I know more or less about your background. So now we will do mainly problem session, but I'm not so much fan of doing only just problem. I will try to give you little concepts behind those problem first, and then I will do the problem. Okay, it will be more helpful for you all, I think. So for today, I have prepared some problems, but don't worry, I don't want these problems to start with. But Pavivda told me to send some problems quickly, so I just written some problem and I send it. But most of them are from, let me see, most of them are from related to subgroups or infinite groups, subgroups, and group homomorphism. So nothing difficult is there. Okay, but we will do most of the things needed. Okay, let me first share the screen. And please try to interact. Okay, as Ovirubda already said that no question is silly. Okay, so you are learning, I also learning. Okay, so don't hesitate. I'm just repeating, don't hesitate, just ask your question. Okay, I think my screen is visible to you all. So for today's class, we need some of those concepts. So today's date is 13th of Jan. So let me first ask some question that can find from group. So you all know that group is a set with some binary operations. So my first question for today is, can phi be somehow converted to any group? Phi means empty set. Okay. Anyone? Can phi be any group?
Yes, because it doesn't actually contradict any axiom of group.
Others? Anyone have any different answers?
No, sir, it is not identity element.
Exactly. So the problem is many books just say that S is a set with some binary operation such that there are 4 axioms. First one is closure, second one is associative, third one is the main. There exist E belongs to G or S here such that such condition satisfied. And the fourth one is inverse. So most of the books give this definition, that S is a set with binary operation such that these conditions satisfied. But the point number 3 is the main thing. There exists an element identity belongs to. There is some existence of a particular element. And what I like the definition most is like, say it here at the first stage, that just say it like this, that a group is a pair G comma star. I am just writing the definition because it is at all a problem session for group theory. I should write the definition at least. I like this definition. A group is a pair G comma star consisting a non-empty. Here is, I have already written the non-emptiness. Non-empty set G together with binary operation star, which is from G cross G to G, satisfying the following conditions. Satisfying the following conditions. And those conditions are: first one, associative. It means that A star B star C equals to A star B star C for all A comma B comma C belongs to G, and the second one is existence of neutral element. Neutral element is nothing other than identity element. Somebody calls it neutral element, somebody calls it as identity element. There exists an element identity belongs to G such that A star identity equal to identity star A equals to A for all A belongs to G. And the third one is existence of inverse. This says that for each A belongs to G, there exists an element B belongs to G, of course depending on A, such that A star B equals to B star A equals to identity, the neutral element. I am not writing the closure property here. Why? Can anyone say?
If it satisfies closure, then it is abelian. It is an abelian group.
No, abelian groups are different, right? Abelian groups mean abelian means A star B equals to B star A for all A comma B belongs to G. This is what abelian says. The abelian is different. Anyone?
Since G is here algebraic structure, so it does not need closure property.
Because the closure property we don't need because of this part, right? I am defining it to be the binary operation satisfying those conditions. And according to the definition of binary operations star G cross G to G, I am defining the function, some function I am defining from G cross G to G. Not function, this is the binary operation, and the map, I can say map. A map G cross G to G. So it will end up on G, right? Because the codomain is G. The range is G, codomain, subset range, we don't need that much for closure, right? Because this is the definition. And this side is G. So what will some under star, the operation will end up in the element of G, of course. So we don't need the closure here. This definition itself includes the closure property in the statement of binary operation. So there's nothing else, the same definition, just some different language. So this is the definition of group. Okay. So what we will need today, some basic concepts. I will just recap very quickly. Some basic concepts for today's problems. Okay. So first one, of course, you all know that what is subgroup. It is very important. Subgroup is nothing. Subgroup is nothing but let G be a group. A subgroup of G is a subset H such that H is a group with respect to binary operation induced from G. Okay. So that means any subset of G under the same binary operation, if we satisfy the all conditions on the properties of group, then we call it as subgroup. For definition, you can see that R plus is group, R is real number, and the subgroup is Z. Z subset of R and Z is also satisfy all the properties of group under the addition. So Z plus is subgroup of R plus. Okay. So this is the definition of subgroup. Okay. So first we will need subgroup and test for subgroup. Just I am writing quickly. Test for subgroup. For quickness, there are two way we can check that it is subgroup, because it's not always we have to see all the properties of the group satisfying. Okay, so we just need something to satisfy the subset. Okay, then the subset will form the group. So there are two steps we have to verify. There are two processes. The first process is, we can see it like this. First, satisfy identity belongs to H. Second, A comma B belongs to H imply AB belongs to H. And the third is A belongs to H imply A inverse belongs to H. So to check these three conditions are enough to see H is a subgroup. Okay, this is the first process. And what is the second process? The second process is identity belongs to H. This is not at all true. This is checking the non-emptiness. Okay, so identity belongs to H, and the second you can check A inverse B belongs to H whenever A comma B belongs to H. So there are two ways. The first one is you can check identity belongs to H, AB belongs to H when imply A dot B belongs to H, and the third one is A belongs to H imply the inverse belongs to H. And there is some second process. Second process is just check identity belongs to H and check that for take arbitrary AB belongs to H and see that where A inverse B belongs to H in H or not. Okay. So these two processes are there to test whether a subset of a group is subgroup or not. Okay. Okay. So some properties we know that union of two subgroup is subgroup.
No.
So union of two subgroups may not be subgroup. Okay, take 2Z union 3Z. Example, okay. And check, this is not a subgroup. And the second was intersection.
Yes, always.
Intersection of two subgroups is a subgroup. And even I am saying arbitrary intersection of subgroups are subgroup. Arbitrary intersections means there may be finite number of subgroups we are intersecting, there may be infinite number of subgroups we are intersecting. That doesn't matter at all. Arbitrary intersection of subgroups is subgroup. Okay. Now for today's class, we need some things. So what do you need? We need just subgroups generated by a subset. Anyone know this concept? Subgroups generated by a subset. We need this concept. So S is a subset of G where G is a group. Now our question is, what do we mean by a subgroup generated by S? So subgroup generated by S is denoted by this. So this is the subgroup generated by S, okay, which is nothing but all the subgroup of G containing S and their intersection. So what is the definition for this? This definition is like this. We are defining it like this. The intersection of H belongs to this H, where this is all subgroups of G containing H. This is the definition. This is the definition, okay. So we are just taking all the subgroups which contains H and taking their intersection. And we know that arbitrary intersections of subgroups is subgroup, okay. So that means that this notation, the subgroup generated by S, is at all a subgroup. We are just taking all those subgroups, all those subgroups which contains H and taking their H, not H, S. All those subgroups which contains S and taking their intersection, okay. So this is subgroup generated by a subset. Because we know this, right? If the definition is not clear, how will you solve the second question? Every finitely generated subgroup of Q plus is cyclic. Because you don't know what is the meaning of finitely generated subgroup, right? So finitely generated subgroup means this subset, what we are talking about, this H subset must be finite. So we know at least 2-3 things about this definition, subgroup generated by subset. Otherwise, it's meaningless to solve this kind of problems. So just bear with me, just 1 or 2 minutes more, then we will finish about the prerequisite for today's session. So another point, we can show that this will be equals to nothing. So we need some description, right? This is the bigger picture and you can't make it smaller because this is some hectic expression. Just taking all the subgroups which contains S and taking their intersection, you can't elaborate in mathematical word and you can't work with it. Work with this definition. There are two types of definition. Yes?
Sir, you have written that the within the box that S generated is equals to intersection of I think that will be H belongs to GS. That will be H, I think, within the index.
Yes. Intersection will be H. Yes. And this class is all subgroups of G containing. Yes.
Sir, I think each subset of G3 instead of belongs to.
Yes, again, please come again.
I think each contains is I think, since intersection of each belongs, each subset of G3 means that intersection of all subgroups of G.
No, please see the definition of the script CS here. What does script CS means? It means all subgroups of G containing S.
Okay.
We are picking H from CS, script CS. That means we are picking a subgroup which contains S and then taking their intersections. So we need some description for subgroup generated by a subset, right? There are two types of definition. One definition is for understanding. So this is a definition. This is good for our understanding. But we need a definition by which we can work on. We can solve problems, right? So there is a theorem saying that this gives the mathematical description of subgroup generated by a subset. Okay. This says that the subgroup generated by S is nothing, just A1 to the power E1, A2 to the power E2, up to AN to the power EN. Okay. Where N belongs to natural number and AI belongs to S and EI belongs to +1, -1. For all I belongs to 1, 2, up to n.
Sir, can we take any integer as EI? I mean, can we take AI as any integer other than +-1? I think.
EI is not
Mm.
integer. EI is EI belongs to +-1.
Actually, I would say that if we take any EI, I mean, if we choose EI as integer other than plus,
But
then I
I
think
am you are telling this like this, right? AI A1 to the power let's say K1 up to N to the power
yes,
K,
yes.
where Ki belongs to integers. Okay, but I am just removing your difficulties more, right? Because AI to the A1 to the power K1, you can write it like this: A1 up to A1 K1 times, right? Where all of them has power 1, right? You get my point.
I mean, so those expressions are equivalent.
Same thing. You can bring it any expression into other, right? Just break it like this. If A1 to the power K1 is there, just write K1 as 1, 1, 1, 1, 1, K1 times, and break it like this. You know that A1 to the power M plus N equal to A1 to the power M plus A1 to the power dot A1 to the power N. Just break it like this. So this will be enough, +-1. We don't need all Z, okay? So this is a good definition because we can work with this. Because now we have description how a subgroup generated by a subset looks like. Okay, so these two are important things. Anybody have any question? Any question you can ask me. Okay, anytime you can stop. Yes.
In the above definition that you already just given, that AI can be distinct or always.
No. There is no distinctness. Okay. What Saurabh was trying to say that you can write it like this also. A1 to the power K1 up to AN to the power Kn. Okay. For this expression, to bring it into this expression, we just need to write it like this: A1 times A1 K1 times dot 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 AN dot 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 AN. This is Kn times. Is it clear?
Yes, sir, clear.
So it can be repeat. Okay, so anybody have any question, you can always ask me. Okay, you can stop me anytime. So definition. A group G is said to be finitely generated if there exists a finite subset S of G such that the subgroup generated by S is equals to G. Now, can anyone tell me that cyclic group is finitely generated?
Yes.
Yes, obviously.
Because the generator is cardinality of the generator set
Singleton.
One.
singleton. So observation when S equals to singleton A, then we call G to be cyclic subgroup. Okay, and we write it like this. The generated subgroup equals to the subgroup generated by A equals to G. And this means A to the power n such that n belongs to natural number. What everyone was
Oh.
asking, that it can plus minus 1 is enough. This is same definition, right? This is same as A times A times A. This is n times where n belongs to natural number.
Sir, then A inverse, how is the element A inverse in this set?
Please again.
If the subgroup generated by A is the collection of all such expression of form A to the power n, যেখানে, where n is in the natural number, then how is the element A inverse or inverse
Just
element?
Just understand, I am just defining it to be the infinite thing, okay? But I am not defining it like for finite step or something. I am just defining that the subgroup generated by A for an arbitrary group G is nothing but A to the power n, n belongs to integer. And now you can say your question, n belongs to natural number. And so say your question, please. Sorry, n belongs to integer. Oh, your question is this,
Actually,
right?
that is
Oh,
what I want to say.
Okay. Sorry. So this is the definition, okay? And you can see that these two definitions are same. Nothing else. You can write it like this. The powers are 1 here. So plus minus 1 is enough. Okay. So now what we can do, I guess more or less we can able to solve now. Okay, some questions.
Sir, after this group homomorphism portion, will group actions like topic
Yes,
stuff?
of course, we will do group action. So I will come into this matter, that what type of exams, what type of questions we need to solve, okay, or what type of exam. But I will come about this. So again, something, I guess order is clear for everyone. I'm not telling the definition of order of an element. And the next thing we need is index. So H be a subgroup of G, then index of H in G is cardinality G by H. Okay. Now how does it make sense? Is it all right makes sense that cardinality of G divided by cardinality of H? And why?
If G is infinite, if cardinality of H or cardinality of G is infinite, then it does not make sense. But this expression makes sense by coset decomposition or.
Okay, so let first just finite. I am writing it. Then it makes sense.
No, actually, I want to say that this expression always makes sense. I mean, irrespective of whether G is finite or not. I mean, the cardinality of G, if I mean,
I am just
collection
asking
of all
that
left
can you
cosets.
write always this? When you can write this?
No. This possible if only if G is finite.
If G is finite, then you can write this. Of course you can write this, but my question is why you can write this? Why this is well defined? This thing.
By Lagrange theorem.
By Lagrange theorem, this is well defined because we know Lagrange says that if H is, this is my definition for subgroup, okay, subgroup notation for subgroup. H is subgroup of G, then order of H, a finite, let's say, okay, order of H divide order of G, finite. Okay, so Lagrange says this, then it makes sense as the denominator divides the numerator. So this is some number, good number, okay. Okay, and we all know that normal subgroup, we all know definition of normal subgroup. I am not writing the definition because it will be so long, then it will be a theory class. So normal subgroup, and when there is some normal subgroup H, let H be a normal subgroup, then G by H makes sense as G by H is group under the operation defined as
If and only if H is no.
okay, but H is normal, I have already taken, okay, H is normal. So under the operation is like this. The elements, first write the elements, G by H, elements are this AH such that A belongs to G. This is the elements. So the operation is A1H dot A2H will be A1 dot A2 of H. So this is the definition of the operation, okay. And you can see that all definitions of groups are satisfied by this operation. These operations, operation of G, okay, this dot. So when H is normal, G by H forms a group, and converse is also true. When G by H is a group, then H is a normal subgroup. So G by
I mean
H,
under this operation, or
yeah, again, please.
do you want to say that when G by H is group under this operation, then it is
Yes,
normal,
under
or
this operation.
under other operation?
Can you define other operation? This is a very big question. We have this kind of operation from where G by H quotient group comes from, okay, but can you define a general another operation? This is a very big question. We don't have such at all. I mean, we don't know as such, because if you study quotient group properly, then you can see that for this definition we need normal subgroup. So the motivation behind the normal subgroup was this definition. To make this at all a definition, a good binary operation, we just follow the back steps, and we'll end up with some condition. We'll end up with some condition where we need that H to be satisfy this condition, and that is the condition for normality. Okay. Is normal subgroup of G. Okay. So please quickly revise all this. We will start, I guess, 2 or 3 minutes, in 2 or 3 minutes solving the problems. Okay. So we have defined the definition of group, you all know. Abelian group, you all know. Some basic concepts such that subgroup, test for subgroup, union of subgroup may not be subgroup, intersection of two subgroups always a subgroup, even arbitrary intersections of subgroups are subgroup. Then subgroup generated by a subset is nothing but take that subset, take all the subgroup containing that subset and take their intersection And as we know from above that intersection of arbitrary number of subgroups is subgroup, it will be a subgroup, and we denote it like generated by S. And there is another definition of subgroup generated by S. This it is the smallest subgroup containing S. Actually, it is the smallest subgroup of G containing S. And we can show these three definitions equivalent. But again, I am saying this is not a theory class. Then you need to do foundation course because it will take long times. So that's why I'm not proving those statements. So subgroup generated by a subset is like this. And for mathematical description, this is the mathematical description of subgroup generated by S. And again, when S, the set S is finite, S has finitely many elements, and subgroup generated by S equals to G, we say that G is generated by finitely many. G is generated by finitely generated group. G is finitely generated group. Okay. As from the definition, it is evident that why we defining like this, because S is finite, S has finitely many element, and S generates G, so the G is finitely generated. When S is singleton, we say this is cyclic group. And we give the definition of normal index. Index is well defined for Lagrange. Normal subgroup. Under this operation, G by H is group. H is normal subgroup if and only condition. Okay. So now we can start. So the first problem. Q has no finite index subgroup. How will you show this?
I think it should be Q has no finite index for a subgroup. Otherwise, G itself is a finite index subgroup of index 1.
Yes, of course, proper. Yes. He has no proper subgroup of finite index. How will you show this?
If we take any subgroup H, and then we can show that H equal to Q.
Okay, let H.
If it has a finite index.
Okay, let H be such subgroup. H not equal to Q.
And then we can if index of, and let assume that index of H in Q is M. And then if we take any element Q, small q of Q, then QH is a coset of H. And since Q is abelian, so H is normal in Q, so we can so the cosine group Q cosine H may make sense. So HQ is an element of the group Q cosine H. So HQ, so the order of HQ divides M, and hence Q to the power M, I mean M times Q plus H equal to H. So,
okay, so you are trying to, your claim is like this, right? M times Q belongs to H.
Yes, for all Q belongs to Q, and then we can show that MQ belongs to H for all Q belongs to Q.
Okay, so I am doing it rigorously and step by step. If Q by H equals to cardinality of Q by H equals to M, then there are M many elements, as of course Q is abelian, then H must be normal, because any subgroup of abelian group is normal subgroup. Then Q by H has group structure, right? So let it has M many elements, so it has M many elements. So Q1H up to QMH. These are the all elements, let's say, representation. Now, as these groups, this group has order M, right? And arbitrary element of Q by H will look like small qh. This is the elements look like. And by again Lagrange's theorem, that if the order of the group is n, we know that if order of G is equals to n, then for all A belongs to G, A to the power order of G equals to identity, right? Simply A to the power n equals to identity. This we all know. So this group look like any particular, any arbitrary element look like QH. Okay. Then and the order is n. So this will imply QH whole to the power m must be equals to identity of Q by H. And identity of, I am writing like this, identity of Q given H. This. And what is identity of Q by H? You
H.
all know that this is H, right? And from this definition, QH whole to the power m means QH times QH dot, of course, how we define the operations, QH. This is m times. This is equals to H. And this will imply, by our definition again, just take these things. This will be equals to Q dot up to m times. This was our definitions for the operation. Times H equals to H. This will imply Q to the power m H equals to H. And this will imply Q to the power m belongs to H. We all know the Coset condition, by Coset condition, okay? AH equals to BH imply A inverse B belongs to H. We know this, right? So by this, okay. So, sorry. So Q to the power m belongs to H, right? Now, if Q to the power m belongs to H, and what does Q to the power m means? Q to the power m means Q is operating m times, and the operation is addition, right? So you can write NQ, because this is right? Q plus Q, because the operation is addition. Q to the power m means Q operating m times, but the operation is addition, right? See, m times. MQ belongs to, I'm writing like this, sorry, H, okay. So it implies we are taking, we have taken arbitrary Q belongs to Q, small q belongs to capital Q. So it implies that for all small q belongs to capital Q, m times small q belongs to H, right? And this implies that m times capital Q contained in H. This is clear up to this? Up to this, is this clear?
স্যার বলছি যে ওটা কন্টেন্ট হলো, কিন্তু ওই এমকিউটা যে এইচ এর সাবগ্রুপ হবে ওটা কি করে বলছেন?
সাবগ্রুপ বলি, আমি কন্টেইনমেন্ট দেখিয়েছি।
ও আচ্ছা আচ্ছা, ঠিক আছে ঠিক আছে।
Okay. So MQ contained in H. Now claim MQ equals to Q. This is our claim. MQ equals to Q. So we all know that to see two sets are equal, we have to show A equals to B. What we have to show? We have to show A contained in B and B contained in A. So this is the technique. Okay. Anyone asking anything?
Clearly, MQ is subset of Q, and
Yes, of course, because
the converse in inclusion. If we take any element small q of Q, then Q can be written as Q equal to M times Q by M, where Q by M belongs to Q.
okay. So first one is MQ contained in Q. Now elements of MQ is of the form elements of MQ equals to M times small q, where Q belongs to capital Q. Rational. Now M is integer, Q belongs to capital Q. So of course M times M integer means M belongs to Q. So elements of Q times elements of Q must be elements of Q, right? Imply M dot Q belongs to capital. So this implies that MQ subset of Q. So this size is trivial, okay? And for that side, Q subset of MQ, we just take Q belongs to Q. So write Q as Q equals to M times Q by M. Now M is integer. So M times Q, and Q is rational. So Q by M belongs to rational. And M times Q by M. So it is a rational number Q. Okay. So imply Q belongs to MQ. Which imply Q contained in MQ. Now from 1 and 2, 1 and 2 imply Q equals to MQ. And if Q equals to MQ, and we have seen this, then it implies that Q contained in H. Now, H is a subgroup of Q. The definition of subgroup itself says it has to be first subset of that group. Now, H is subset of Q, and Q contains in H. So, this implies that H equals to Q, which is contradiction, right? We have taken H to be not equals to Q. So, our assumptions were wrong. And what was our assumption? Our assumption was this: finite index. So there is no finite index subgroup of proper, of course. Okay, so is it clear for everybody? Otherwise, I have to repeat it. Any doubt? Anything? Okay, so I'm assuming.
তো বলছি এই অঙ্কটা মানে এটা তো একটা কন্ট্রাডিকশনের পদ্ধতিতে করলেন, কিন্তু আমি এইভাবে ভাবছিলাম যে ধরুন মানে এই মানে একটা প্রপার সাবগ্রুপ আছে যেটা হচ্ছে ইনফাইনাইট ইন্ডেক্স, তো আমি সেখান থেকে যদি আমি কন্ট্রাডিকশনটা দেখাই, তার মানে যদি সাবগ্রুপ থাকেই তাহলে ওটা ফাইনাইট ইন্ডেক্সের হতেই হবে, এরকম করে কি দেখানো যাবে?
দেখানো যেতে পারে, কিন্তু ইনফাইনাইট ইন্ডেক্স নিয়ে কাজ করবে কি করে? হাউ ইউ উইল ওয়ার্ক উইথ ইনফাইনাইট ইন্ডেক্স? But this must be difficult, right? You don't have any expression, you can't use this property also. Because let just first think about this. To do some problem, you have to think that what you can use to that problem. And I am assuming such things that my problem gets easy. So I am assuming such things that I can use most of the theorems, most of the statements. And if you first assume some difficult thing, then it will be difficult to apply some theorems or properties like this. So it's more important first thing that what you can assume that you have more tools to solve the problem. And of course, in mathematics, you can do a problem in 1,000 ways. There is no hard and fast tool that you have to do like this. Okay.
ওকে স্যার।
Okay, so the next question is very interesting. Okay. This is very interesting and very important question. I think like every interviewer like this question. Every finitely generated subgroup of Q plus is cyclic. Anybody want to try? Please.
If we take any finite, if we take any such subgroup, then it has a finite generator. Let's say S equal to Q1, P1 by Q1, P2 by Q2, dot 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 Pn by Qn. And if we take any element of
just wait for a minute. Let me write. Is B the set? Just wait for a minute. Just wait for a minute. So sorry for interruption. Okay. So P1 by Q1 up to Pn by Q such that P1 by Q1
Yes.
by Qn
Yeah.
equals to Q, right? And then
If we take any element of for N1 times P1 by Q1 plus N2 times P2 by Q2 dot 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 plus NK, NK times PK by NK, then we can express this element as some, some power of
please come again, please. Sorry. What are you telling? The elements?
if we take R1 times P1 by Q1 plus R2 times P2 by Q2 dot 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 plus Rn times Pn by Rn, then it will look like some integer multiple of 1 by Q1 Q2 dot 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 Qn.
What is your claim? You are claiming
My
which will be
claim is that
the-
that this element is in the subgroup is in the cyclic subgroup generated by 1 by Q1, 1 by Q2 dot 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 1 by Qn, and then since every subgroup of cyclic subgroup since every subgroup of a cyclic group is cyclic, so and then it will follow that the group generated by S is of course cyclic, since
Okay.
it is contained in that.
So for everybody, what is telling that S be the set this such that there exists a subgroup which is generated by these elements, because we have to take the contrary, right? Every finally generated subgroup of Q plus is cyclic. We have to, this is true statement, of course, first of all. And so we have to take a finite set. Let's say S be the finite set, P1 by Q1 up to Pn by Qn, and the subgroup generated by that set B is equals to this. Okay, let's say H, a subgroup. This subgroup, okay. We have to show H is cyclic. To show H is cyclic, you have to show this, right? According to the question. Okay. So claim is this: H contains in 1 by Q1 up to Qn, sorry. This is my claim.
Sir, can
Of course, আমাকে তার জন্য দেখাতে হবে. So we have to show that if we can show that if we can show that 1 by Q1 times Qn, this contains P1 by Q1 up to Pn by Qn, then 1 by Q1 times Qn contains H. Is this observation clear? Can anybody tell me why this will be true?
Since S is the smallest subgroup containing, so since S is the smallest subgroup containing H, and and these, I mean, the cyclic subgroup generated by 1 by q1 dot 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 1 by qn. 1 by q1 is the is one such subgroup containing that the elements p1 by q1.
Exactly. Exactly. So if you remember that I have told you the definition little earlier, that there is another definition, that this means, this bracket, this means the smallest subgroup generated by S, right? The smallest subgroup containing S. The smallest subgroup containing S. This was the another definition I told you. So if we can show that these all elements contain in this. Now this is a subgroup. This is subgroup generated by 1 by q1, q2 up to qn. So this is by definition a subgroup. So this is a subgroup containing p1 by q1 up to pn by qn. This set is. And is the subgroup generated by S is the smallest subgroup containing S. Means this is the smallest subgroup containing P1 by Q1, P2 by Q2, Pn by Qn. And if we can show that this subgroup also contains P1 by Q1 up to Pn by Qn, which is S, nothing but S, then it will imply that this will contain H, because H is the smallest subgroup containing those elements. Is it clear? Is it clear?
Clear, sir.
So, and this is easy, right? Pi by Qi. How we will generate this element? How you will generate?
We can write this as in the denominator product of qi, I run from 1 to sorry, product of qj, j run from 1 to n, and then in numerator pi times q1 q2 dot 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 qi minus 1 times qi plus 1 dot 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 qn.
So this will be q1 times qi minus 1 and qi plus 1 up to qn.
And if n is, I think, 1, exactly 1, then we have
So
nothing
you
to
don't
prove
have to
by
think about it. This is more general. Okay. So this is the case. You can see, right? This is the case, right? This means you are operating 1 by q1 times qn plus 1 by q1 times qn dot 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 plus 1 by q1 up to qn. This total pi q1 qi minus 1 qi plus 1 qn times. This is the natural number, right? This is a natural number. So these times make sense. So you are operating these elements that much of time.
But I think if pi times q1 q2 dot 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 qi minus 1 qi plus 1 dot dot qn is, if this integer is negative, I think we
But
can write in this way times.
that doesn't make sense problem. Okay, because negative means that inverse must be there, right?
I think then
This will not create any problem. If you get one, you will get the another. You have to just take with the minus, right? 1 by q1 q2 qn, you just have to take with the minus, negative sign, the inverse of 1 by q1 q2 qn. Either you have to play with the q1 1 by q1 up to qn, or you have to play with the inverse of 1 by q1 up to qn. You are talking about minus, then you have to play with the inverse of 1 by q1 up to qn. Nothing else. So it will not be any problem. So if you operate these times, then you will get this element. Okay, this is a calculation, right? You cancel out numerator and denominator, it will be pi by qi left with. So imply Pi by Qi belongs to 1 by Q1 up to Qn. Okay, for all I equals to 1, 2 up to n. Now this is cyclic. Generator is 1, right? Single generator is cyclic, we have defined. Now Pi by Q, this will imply H contained in 1 by Q1 up to Qn. And by our observation. And this is cyclic. This is cyclic by our definition of cyclic group, the single generator. And this is a subgroup. This is at all a group. And H is contained in
Subgroup of
this.
a cyclic is cyclic.
Yes. So subgroup of a cyclic group is cyclic. So H must be cyclic. And we know that subgroup of a cyclic group is cyclic, imply H is cyclic. So any finitely generated subgroup of Q plus is cyclic. We have shown this. Okay, just the one single problem, another problem. We will end today's session. Okay, just do this. This is the question for TIFR.
Sir,
Yes, please.
স্যার বলছি একটা জিনিস মানে একটু ডাউট হচ্ছে, সেটা হচ্ছে যে এইচটা সাবসেট অফ ওই জেনারেটেড বাই 1 বাই Q1 Qn অব্দি তো করলেন, ঠিক আছে,
হ্যাঁ।
কিন্তু ওখানে এইচটা তো সাবগ্রুপটা মেন গ্রুপটা, তাই তো? এবার এইচটা যে এবার ওটা সাবসেট দেখালাম, কিন্তু এইচটা যে ওর সাবগ্রুপ হবে সেটা তো দেখালাম না।
Interesting fact. Try at your home that.
I think A and B
No,
are
no,
two
he will try. He will try. Okay, let him try. H1, H2 subgroup of G, bigger group, and H1
subset of
contained in
H2.
H2. Okay.
Then H1 is sub.
Sorry, H1 H2. Okay. Let it be. Yeah. Then H1 contained in H2. Then H1 is subgroup of H2.
ও স্যার এই প্রবলেমটা জানি, ঠিক আছে বুঝে গেছি।
Okay. So the
I
subgroup
think being subgroup is the property of the set itself.
The definition of subgroup was the induced binary operation from the mother group G. Okay. So it will not affect, right? Because every binary operation H1 and H2 is operation of G. So you can take it as the parent group. So it will not affect. So the operation is clear. The main thing is the operation. Okay. So the last question we will do today is a question for TIFR. This is a question, I guess 2023 or 2022. TIFR asked this question. Okay. So G be a group. Let A, B belongs to G such that order of A, order of B is finite. Then order of AB is finite. True or false? Try, anyone try, please.
Sir, if we take infinite dihedral group, then I think
Dihedral group.
I mean,
You-
if A and B do not
স্যার যে কোনো একটা নন এমটি সেট নিচ্ছি এক্স, এবার তার উপরে পাওয়ার সেট নিচ্ছি আর সিমেট্রিক ডিফারেন্স নিচ্ছি, তো এখানে এটা একটা গ্রুপ ফর্ম করে, প্রত্যেকটা এলিমেন্টের অর্ডার 2 করে হয়, আর ওই কম্পোজিশনটা স্যার দেখছি।
তাহলে তো ওটা তো কিছু বলাই যাবে না, মানে প্রত্যেকটারই যদি অর্ডার ফাইনাইট হয় তাহলে তো আর কিছুই বলা যাবে।
আর একটা এই কোয়েশ্চেনটা শুনে আমার মনে পড়লো, after hearing this question, my mind said that there is a beautiful question. If every non-identity element of a group is of order 2, then the group is abelian.
হ্যাঁ, এটা তো একটা প্রপার্টি আছে। হ্যাঁ
তাহলে তাহলে তো পাওয়ার সেট অফ সিমেট্রিক ডিফারেন্স কাজ করবে
স্যার, এটা
সেক্ষেত্রে।
তো ওই সেলফ ইনভার্স হয়ে যায়, ওখান থেকেই প্রুফ করা যায়। হ্যাঁ
হ্যাঁ, তাহলে সেক্ষেত্রে কি পাওয়ার সেট অফ সিমেট্রিক ডিফারেন্স কাজ করবে? যদি every element, if every elements of or non-identity elements is of order 2 in power set of some natural number with symmetric difference, then it will be abelian, right? According to a definition.
হ্যাঁ স্যার।
Then how will it satisfy this counter example? Because
হ্যাঁ, এটা হবে না। হ্যাঁ, অর্ডার অফ
because
এবিটাও 2 হয়ে যাবে। হ্যাঁ হ্যাঁ
abelian it will end up into the. So what is the motive behind? So there is
I
something.
think if A and B do not come,
No, actually, first try to learn the motive. If you want to construct some counter example, you have to think something. There is no thing called just remind it. I don't believe this. You have to think in some way that you can find counter example. So to find counter example, you also need concept. There is nothing called remembering some things or. Okay, so the main concept behind this is first you should try with matrix group, right? Because why I am telling you, and for matrix group, the smallest, the easiest matrix group you can think of the 2x2 matrix, because this is the easiest matrix. Okay, and what will be your target? Your target will be something that product of A and B will be a diagonal matrix. Here A, here B, here 0, here 0. If this happens somehow, then after you operate n times or 2n times or any times, what will be this? Can anybody say me?
A to the power n 0 0
B to the
B to
power
the
n,
power n.
right? This will be like this: 0, 0, B to the power n. Okay, and you all know that for the matrix group, the identity element is identity matrix. And if A and B greater than 1, let's say 2 or 3 somehow, then it will not give you 1 anytime. So that will be your counter example. So the thought process, the thinking behind this is this: somehow we need two matrix where their multiplication can be the diagonal matrix. This is my thinking process. And we need two matrix such that whose square or cube must be identity matrix. And one matrix is very easy. We all know this matrix, right? 0, 1, 1, 0. From where I found this? Can anybody tell me? We want some finite order element, right, in some matrix group. And the first element came into my mind is this element. Why? What is my thought process behind this? What type of matrix is this? 0, 1, 1, 0. You have studied.
Orthogonal.
Orthogonal is okay, but this is a special type of matrix, right? Cos theta, sin theta, sin theta, minus
Rotation matrix.
rotation, deflection, all kind of matrix are involved in this. Okay, and if you
ACL
can,
to what?
huh?
ACL to what?
Yes. So rotation, deflection, this kind of matrix is very good matrix, and we can construct this. Okay, and if you operate 2 times, this will be give you identity. And another one is 0 to 1/2 0. Again, you can try. This will also, after operating 2 times, it will give you this. And if you product these two, this will give you 0, 1, 1, 0, 0, 2, half 0. You product these two, and this will give you like half 0, 0, 2 or something. This will give you this. Now operate this any times. This is a diagonal matrix. You operate any number of times, it will not give you identity, because you know that diagonal matrix 2 to the power n 1 it is not possible. And from where these two metrics came from, these also lie behind some concept. This is some concepts of linear algebra. I don't know how much you know about linear algebra, you all, but this is also concept of linear algebra. This is no out of blue question. Okay.
স্যার বলছি আমি একটু অন্যভাবে ভেবেছি বলবো।
Of course.
বলছি যে এখানে তো অর্ডার অফ এট মানে আমি জানি না মানে এটা আদৌ ট্রু হবে না ফলস হবে,
No,
তো
no,
আমি
অবশ্যই, হ্যাঁ।
মানে পরীক্ষার পয়েন্ট অফ ভিউতে বলছি যে
হ্যাঁ, হ্যাঁ।
অর্ডার অফ এটাকে আমি ধরে নিলাম এম আর
হুম।
অর্ডার অফ বিটাকে ধরে নিলাম এন,
হুম,
তাহলে হচ্ছে এ টু দি পাওয়ার এমটা ই হবে আর এ
হুম,
বি টু দি পাওয়ার এনটা ই হবে। এবার আমি দেখছি তাহলে স্যার ওই এ বি টু দি পাওয়ার এলসিএম অফ এভেনটাও তো ই হবে।
No, that's the problem. There is no commutativity here.
ও আচ্ছা আচ্ছা,
You are assuming commutativity.
হ্যাঁ
You
এখানে
can't,
তো বুঝতে
you
পারছি।
can't change the positions, and you can't group A together and B together. That's the problem here.
তাহলে স্যার মানে আমি একটা ইনটিউটিভ আইডিয়া ভাবছিলাম যে এ বি
হুম।
টু দি পাওয়ার এলসিএম ওই এটা আর কি, ওটা তো ই হবে যদি মানে ওটা কমিউটেটিভ হয়, তাহলে আমি
Commutative.
কাউন্টারটা এমন ভাবে খোঁজার চেষ্টা করি যে
No,
যেখানে কমিউটেটিভিটিটা হচ্ছে না, তাহলে
first
স্যার
order. Hmm.
হ্যাঁ, তো স্যার ওই জন্যই তো ম্যাট্রিক্সের এই গ্রুপটা, কারণ এখানে তো ম্যাট্রিক্সের গ্রুপটা তো কমিউটেটিভ হয় না।
Of course. First target is
মানে
this.
এইটা একটা পরীক্ষার পয়েন্ট অফ ভিউতে আমি মানে কাউন্টার এক্সামের মুখস্থ করিনি, কিন্তু এইভাবে একটা কাউন্টার বুঝতে
Obviously. First, it's must not be commutative. Then we have to find some non-commutative group. Then matrix group is example, and the second
সেখান
one is
থেকে আইডিয়াটা চলে এলো। হ্যাঁ
how we have to construct some diagonal matrix. We have to construct product, and these two matrix also the counter example comes from some linear algebra aspect. If you have good hand in linear algebra, you can just think like this. We need two types of matrix and the square must be identity, then you can easily find it. Some eigenvalues,
নীলপোর্টের
eigenvectors.
ম্যাট্রিক্স কি?
No, nilpotent matrix will be give you zero, right? To the
হ্যাঁ
power
হ্যাঁ
n
ও হ্যাঁ
equals to
জিরো
zero
দেবে।
matrix.
হ্যাঁ হ্যাঁ ঠিক ঠিক।
This you can say involutory matrix. But that is a different issue. But okay. But okay, so we will stop here today. কারো কোনো question?
স্যার বলছি প্রবলেম সলভিং এর জন্য মানে একদম কি ভালো বই ফলো করা যেতে পারে? একটু ভালো ভালো লেভেলের প্রবলেম আছে অ্যালজেব্রাতে।
গ্রুপ অ্যাকশনের সংক্রান্ত মানে ব্যাপারে এই কোর্সটার সাথে আর কি কোনটা মানে প্যারালালি রেফারেন্স হিসাবে ওটা সুইটেবল হতো, ডামিট ফুটে বা অন্য কিছু?
গ্রুপ অ্যাকশন ডামিট ফুটে ঠিক আছে। গ্রুপ অ্যাকশন আর কোনো বইতে আমি তো এই মোমেন্টে ফার্স্ট লেট মি স্টপ দ্য রেকর্ডিং, দেন আই উইল জাস্ট ওয়েট ফর আ মিনিট।